This is for physics for class 12, for 11 and 12 for both of them. This is for physics for class 11 both of them, and this has been questions is been selected for competition point of view. Competition from competition point of view. For class 11 and 12, and this has been done from competition point of view. So I have selected this question. So here, why I have selected this question, the main point is, there are many type of questions, but why I have selected this question, because here you will find there are 3 chapters are involved while solving this question. So such type of questions are important from competition point of view, because here here 3 chapters are involved. Now first of all, you give a stress on the question. The magnetic field B is confined to a region R less than equal to A, and less than equal to A, and the points out of the paper, the z-axis R is equal to 0 being the center of the circular region. That means here it has been told about the magnetic field confined to a region R less than equal to A. That means, see, this is your y-axis, and this is your, say, x-axis, and this is your z-axis. So R is equal to 0, this is 0, and a magnetic field B is confined to a region R less than equal to A, and points out of the paper are the z-axis, and R is equal to 0, the circle of the circular region, a charge this of radius this and mass m lies in the xy plane. That means your this ring here, this is a ring, it lies in the xy plane with its center at the origin and radius b, that is b, this is greater than a. That means B is greater than A. That means your magnetic field, this is your magnetic field, and this is your ring. The radius of this magnetic field is R, sorry, not R, that is A, and the radius of this ring is B. This is B, radius of this ring is B. That means this picture is somewhat like this. This is xy plane, and here this is your z. It is somewhat like this. This is the ring, and the magnetic field is, this is the magnetic field, somewhat like this in the xy plane. This is xy plane. It is somewhat like this. So, and next you see that the ring is free to rotate, this ring is free to rotate and is at rest. The magnetic field is brought to 0 in time delta t. Magnetic field is brought to 0 in time delta t. Your magnetic field is out of the paper, and your magnetic field is brought to 0 in time delta t. So what does this speaks? What does this tells about this magnetic field? That means there is change in magnetic field. This tells about that there is change in magnetic field. This is the important point. So my main objective is that how to read this question, and I have selected this question because here 3 chapters are involved. You will know about it later on. So here you see the magnetic field is brought to 0 in time delta t. That means there is change in magnetic field. So when there is change in magnetic field, that means what happens? An induced EMF is produced. An induced EMF is produced. Where? Sorry, produced. Produced where? Induced EMF produced in the ring, here, this ring. Induced EMF is produced where? In the ring. The induced EMF is produced. So, your induced EMF, that is, we know that V is equal to E into D. We know the relation. This V is nothing but this potential. This is nothing but this is potential because this is induced EMF. This is EMF. This is your EMF. So this induced EMF is produced in the ring. So here, since this induced EMF is produced in the ring, so what happens? So this is E and electric field, and D, this is the distance, that is the circumference, that is 2 pi B, ring of the ring. This is the ring. Now you see third important point. That means according to this here, your induced EMF, that is what? That is change of flux with dt. Your induced EMF is, that is change of flux. So again, what is your flux? Your flux is area into B, magnetic field, and time delta t, because here it is given that your magnetic field is brought to 0 in time delta t. That means there is change in time delta t. In time delta t, what was your induced EMF? Your area is constant, but your B is fluctuating. So here you can write this also like this: A, because area is constant, dB by your, you can see delta t. You can write like this also. So from here, what do we find? Now we equate these two. When we, and so here this area, so here this area of this magnetic field, that means this is the circumference, this is the field. So area will be 2 pi A B by delta t. This is the EMF. Now what we are going to do is that I am going to equate it, these two, equate it, that is E 2 pi B, that will be equal to 2 pi A B delta t. So 2 pi cancels. Here E will be equal to A B by B delta t. This will be your electric field. So here again you see that when current is flowing through this coil, that means this ring, that means electric field is produced. And when this electric field is produced, that means there is a force, because due to the flow of the current, naturally there will be an electric field because there is a flow of charge. So when there is, it is in charge. So because there is flow of charge, so because there is flow of charge, that is flow of current, which is created due to the change in magnetic field. So this current, this charge, there will be an electric field, and the electric field will be equal to, there is an electric field. So this is the electric field. So force at any point, this force this force will be how much? This will be the charge, that is the Q, and E. This will be the force. Here the force will be E F is equal to Q. I have done everything in scalar form, so I have not written anything, expressed this in vector. I have written everything in scalar form. So this is the force, because we are doing calculation. So here we are doing calculation. So here I have taken everything in the scalar form. So this force, there is a force acting on this ring. Now here it has been told the ring is free to rotate and is at rest. That means free to rotate. That means this force which is created here, this force will try to rotate. That means when it tries to rotate, that means torque is produced. The fourth important point is that torque is produced. Torque is produced. So see, there torque is produced. Now again, here you can see torque. What is torque? Which you have read in class 11. Torque, that is equal to R vector cross F vector. This is your torque. So now here your R is this radius, this is B. So this will be B, and let me write it again here. So converting into scalar, that is B, and your F is QE. This is QE, and because this is B and F are perpendicular to each other, this B and F are perpendicular, so sin 90 is 1. So this is your torque. Now we place the value of E here. So this will be B Q A B by B delta T. This will be your torque. Your fifth point here. Here you see what happens. A torque is produced. So now here you see change in magnetic field. That means induction effect. And again here V relation with V and E D, that is potential and electric field relation. Then again this is mutual, this is the induced EMF. Now here again this goes to electrostatics, that is force. Now again here this torque goes to your rotational motion. So torque is produced. So now here torque is produced. So sixth important point here, this is your torque produced. So your sixth important point, that is change in angular momentum is equal to torque. Change in angular momentum. This is delta L. What is this? This is change in angular. This is change in angular momentum. This is change in angular momentum. This is the change in angular momentum, that is torque. And I have taken delta T because your time in delta T, the whole work is taking place in time delta T, because it is given here. The whole work is taking place in time delta T. So this is your torque. Now here again one more thing, that is change in angular momentum. So here the ring is initially at rest. See, because this is at rest, so your initial angular momentum is 0. So your final angular momentum L. So this will be L will be equal to torque into delta T. What is your torque? This is your torque. So this will be B Q A B by this BB cancels out. Here E, BB cancels out. Here this B cancels out. So this will be how much? Q A B by delta T. So your torque will be this by delta T into delta T. So this delta t cancels out, and this will be angular momentum, that will be q a b. This will be your angular momentum. Now your last point is that that is the seventh point, is this, that is your angular momentum, that is equal to moment of inertia into angular velocity. This is your last. Now we know that about angular momentum, that is q a b, and here moment of inertia of this ring is mass into radius, that is b square omega. So now here we get q a b by m b square is equal to omega. So this is your ultimate answer. This is your ultimate answer. So that is why I have selected this question, because here you see this is electromagnetic induction. Here there again comes electrostatics, that is you will find this formula in equipotential surface, that is potential and electric field relations. Now here this is again electrostatics, and here this is rotational motion, and here rotational, and again here in rotational there is change in angular momentum. So here again moment of inertia. So here you see you have, this is a very good question, because this compiles 3 or more than 3 chapters together, and it becomes a good revision for you if you solve such type of questions. So from this point of view, I have selected this question. So let me check again the whole thing, if there is anything wrong, because here there is upload is going on. So first of all, let me see if there is anything wrong here, because area of this is the d distance, area, here area, this is pi a square, area of the magnetic field, area of this electric field, that is pi a square. There is a little bit of mistake, because I took the circumference. This is not the circumference, this is the area. So this is not the circumference. So here this will be a square and 2. So now again let me check here. This will be b a square and 2b. So this is a square 2. So again here will be 2a square Turk by 2. So this will be a square by 2. There is a slight mistake. Again here this will be a square by 2, and so this will be 2. So I made a slight mistake, but after all I have corrected it, because this will be uploaded. So here I have, in here A, what did the mistake I have done, that here A is the area of this magnetic field, and I took the circumference. Here this is B, so this is B is the circumference, it is okay. But looking at this, I made the same, I wrote here 2 pi r circumference, but this is the area, not this. Here this is circumference, but here this is the area. So here D is the circumference. This is the circumference of the ring, distance, circumference, but here it is the area, and area of this magnetic field is pi a square. So now I think so everything is okay. BB cancels out, so this will be Turk. that is a change in angular momentum, that is torque. This here, this will be q a square b by 2 m r square, because moment of inertia, m r square, this is moment of inertia. So here now it is okay. So this is your answer. So see how to read, first of all, how to read this question. You might have done this question, but no doubt you might have done, but I have selected this because I have given the whole explanation. From this, here you say magnetic field is brought to 0 in time delta t. That means magnetic field is brought to 0 in time delta t. That means there is change in magnetic field. And because there is change in magnetic field, an induced EMF is produced in this ring. And because this induced EMF is produced in this ring, that means current is flowing through this ring. That means charge is flowing through this ring. That means an electric field is produced. And when there is an electric field, here it says the ring is free to rotate. That means it is free to rotate. That means there is a torque. It is at present rate, but it is saying it is told here that it is free to rotate. That means there is a torque acting here, and so when there is a torque, therefore there is r cross f. And another very important point is, since the questions asks about angular velocity, so when there is angular velocity, there must be a torque. So when there is an angular velocity, this is the main important point, that when there is an angular velocity, there must be a torque. So such type of ideas you must culture. That means such type of ideas, the basics you have to develop, because from here, that means there must be angular velocity, that means there must be a torque. So when there is a torque, if you are able to find the torque, when you get the torque, then everything is clear, because the change in momentum, change in angular momentum is nothing but torque. So because change in angular momentum and delta t, because here it is given the whole incidence is taking place in time delta t. So here also I have taken delta t, because the whole incidence is taking place in time delta t. This is the very important point, time delta t. So here I have taken here delta t, and because your at rest, that means your initial angular momentum is 0, so your final momentum will be this L. So again, angular momentum is related to angular velocity, and by the help of which I am able to find out the value of angular velocity. Now this is another question. A body of mass 0.4 kg moving with a constant speed to north is subjected to a constant force directed towards south for 30 seconds. Take the instant the force is applied at t is equal to 0, the position of the body at that time to be x is equal to 0. Predict its position at t is equal to -5 seconds and 25 seconds and 100 seconds. So you might have done these questions, but why I have selected it to explain something. You might have done it, but why I have taken it, because here some basic concept lies, and so I have taken it. Because my objective is to move from the very base. I do not want to jump direct to a question. I always want to move from the very base. So if your base is clear, if you move from the base, so you will be able to solve this question. And there are some important things which most of the students they ignore. They do not give any concentration or any time to read the question. Just they go fast throughout it, and they use the formulas, and if it comes out correct, then it is correct. But the most important point is that I want to say is that you study this, you read this question takes some time. So here you see that a constant force, a constant speed to north and a constant 8 directed towards the south. That means the body is moving towards north. And here a constant force is acting, that is 8 newtons towards south, because this is your south, towards south. And for time it is given for 30 seconds. Now here the question is here, the instant the force is applied, means at the time when this force was applied, your t was 0, and your position was x is equal to 0. So see here, this is the data given you, and now you have to predict the position at t is equal to -5 second, 25 second and 100 second. So you now here you see the important points here. See, first of all, because the force is acting in opposite direction to the motion of the body, that is body is moving in upward direction 10 meters per second. So here force is acting in downward direction, in opposite direction. So first let us calculate the acceleration, because when there is force there is acceleration from Newton's second law. So this will be, force is in opposite direction -8 and your mass is 0.4. So this comes out to be -80 by 4, 20. So your acceleration is -20 meter per second square. So I have, first of all I have found out the acceleration, and because here the force is acting in opposite direction, because there is a force, so there is an acceleration, and this acceleration is from time t is equal to 0 to t is equal to 30 degrees, up to this your time here. Now here the question asks at t is equal to -5 seconds, that is -5 seconds before this, before t is equal to 0, before t is equal to 0 minus it is. So before t is equal to 0 there was no force, there was no force, that means there was no force, that means it is moving with constant speed. So remember, this is the very important point, at t is equal to -5 second, there is no force, there is no force acting on it. So this is the very important point, no force, that means it is in a constant speed. When it is a constant speed, that means uniform velocity, then at that time your net force is 0, there is an acceleration is 0. So at that time you will be able to use the formula, that is your speed is equal to distance x by t. You can use this formula. So here your speed is how much? 10. So your 10 and your x time is -5. So -50 meter will be your x. Now why I want to tell you this, the more important thing here is that here your, because at -t, because it is given at t is equal to 0, this force starts acting when t is equal to 0 to t is equal to 30 seconds. Before this there is no force, that means it is moving with constant speed, that means it is moving with constant speed. So we can use this formula. This is the very important point. Now again at 25 seconds, so here 25 seconds it is between t is equal to 0 to t is equal to 30. So here your acceleration, there is an acceleration, but remember, since your force F is equal to ma, here this force is constant, this is constant, so here acceleration is constant, this acceleration is constant. So when your acceleration is constant, you can easily apply this formula, s is equal to ut plus half at square. You can easily apply this formula, ut plus half at square. So your this s will be how much? Initial speed 10, time is how much? 25. So 25, and this is half. Acceleration is minus 20, and your time t 25 square. So this comes out to be this much, 250, and this is minus 10, minus 10 into 625. So this will come here, as will be acceleration is negative acceleration, so your it will come out to be so this will be 250 minus 6250, so this comes out to minus 6000 meter. This is minus 6000 meter. So now again you last at 100 second. So for 100 second, you see, you can do it yourself, that is up to 30 second, up to t is equal to 30 second, you will be able to use the formula S is equal to ut plus half at square, because up to 30 second your acceleration is constant. Up to 30 second your acceleration is constant, so you can use this formula. And after 30 second there will be no force. After 30 second there will be no force. So after 30 second, that is 70 second. This is for t is equal to 100 second. So up to t 30 second you can use this formula, because here acceleration is constant. But after 30 second there is no force, that means it is moving with constant velocity. So since it is moving with constant velocity, you can use this formula, speed is equal to distance by time, and here speed is 10 and distance x, and your time is how much? 70. So this will be 700 meter, this will be x, and you calculate for 30 seconds from here, you add this to, this will be your distance, this will be your distance, total distance in t is equal to 100 seconds. Now here there is one more important point here. For here there is one more important point, because up to 30 seconds, no, after 30 seconds there will be no force. So what will be your final velocity after 30 seconds? 1 minute. This is slight mistake here. So what will be your velocity after 30 seconds? What will be your velocity after 30 seconds? This is a very important point. What will be your velocity after 30 seconds? Because after 30 seconds your velocity will be constant. So v is equal to after 30 up to 30 seconds, what is your, that is u plus at. So v will be equal to u 10 minus 20 into 30. So this is comes down to 10 minus 600. So v will be equal to minus 590 meter per second. So this is very important, means up to 30 seconds. That means after 30 seconds there will be no force. So what will be the final velocity after 30 seconds? Your final velocity will be this much. Sorry, 590 meter per second. This will be your final velocity. So now your distance will be, you can there is no force, because after 30 seconds, for 70 seconds it will be moving with this constant velocity. This will be constant, this will be moving with constant velocity. So x will be equal, your s will be equal to x by t. So here s is minus 590 is equal to x by 70. So minus 590 into 70, this will be x. So here you calculate it, that is 7 9s are 63, 3 6, 7 5s are 35, 35 plus 6, that will be 1 4 4 1 0 0. This much will be your meter x. And for 30 second, you calculate the s from here, you add these two and you will get the total distance for 100 seconds.